Okay, good morning to everyone. And we have Fleetwood Mac and Don't Stop. And we've agreed that that is a reference to algebra. You want to think about algebra for the rest of your days, right? Okay, we have a couple announcements that I'd like to present, and one I should have done earlier. We have a change in the webcast, and that's been necessitated by a reduction in funding. And so we have dropped 2 hours of broadcasting in the evening, which made some people upset last night when they didn't find that we were broadcasting. The Math 70 that we are doing now that's being webcast as I speak is then going to be done at 7 to 8, Monday through Thursday, but 5 to 6 on Friday because we had to adjust schedules. And that means we have a new time frame. If you are wanting to see the broadcast in the evening, again 7 to 8, and then we do run the VHS tape in the library. So some changes are happening. They aren't good changes, but nevertheless they are reality. And in terms of homework, I had some requests on email this morning. I didn't have any in voicemail. The request that I had, and I'll start with those, that goes with the material on page 301. And Debbie, if we could cut to the document cam. This is the 71st problem. It's just a fairly typical problem, but as that's on the board, let me write it first, and we'll start there. That's a plus b times an x to the second. Then I have a plus a plus b times x, and then I have a negative 12 times the a plus b. And we can cut now to the board. Now the question here, why is the order of the a plus b and the 12 different than it was in the first two terms? What's the argument?
Because it's a negative 12, not a negative ab.
Okay. One could argue because of the minus sign, but even if it was a plus sign, it would still be there. Why? Where does a numerical coefficient usually go? In the front of some factor containing letters, and that's why. But what you're supposed to observe is the factor contained in each of the three terms. So you're supposed to see that a plus b as a common factor, so we're taking out the GCF, and then we must include parentheses around this, because without the parentheses, you'd only be multiplying b times everything. And that was an issue in some homework last night. This is the trinomial. Now, you have factored out an a plus b. What is understood about this relative to the trinomial? What next step are you obligated to try? To factor the trinomial. Now, it may be a prime polynomial. What are you looking for in the 12? A difference because of the minus sign. So you want a difference of the coefficient of x understood, which is a 1. So if I look at that and I think of the factors of 12, 3, 4, 2, 6, 1, 12, the 3, 4 should hit you as exactly what you want. So I need the a plus b. Then I'm going to have a pair of parentheses here for the two binomials. I know that they must be x and x. This is the nice version, which we are going to migrate to a more difficult version quickly. One of these has to be positive, one has to be negative, and that's arbitrary. If you prefer the negative first and then the positive, fine. But by commutativity, this can be reverse flip-flopped, and it will work. I need a positive with the what? With the 4, and the negative with the 3, so when I do the inners and the outers, I end up with a combination of 1x. That would now be factored completely. And the request that was made, anything from 71 to 74. Let's go back to the document cam. Is it clear to you as you look at those now in retrospect that the same issue is involved in every single problem? It's taking whatever is in common. So if I look at this in terms of commonality, even in the 74th problem, you're seeing the 3m minus n as a common factor. This is an interesting one right here. I would have been inclined to put the k in front and say negative 13k times the quantity 3m minus n. Then the same issue as we come down to the 40. The 40 is in front because that's more common. And then, of course, once you do that, you're left with k squared minus 13k and a plus 40. And I hope you see the factors of 40 as 5, 8, and you're taking a sum, so 5 and 8 give you 13, and you're there. I'm hoping that is an automatic for you at this point. Any questions on that? Pam?
Okay, on 72.
72.
I just want to make sure that
Okay.
that's a prime trying to, I mean, you can't break it down any further.
Okay, 72. Let me write the first step. I'm not going to write the problem, but in 72, let's go to the document cam for a moment. Thank you, Debbie. I'm going to pull out the x plus y, so I'll just do that immediately. And I have n squared plus n plus 16, is that correct? Now, the question that's being asked as we look at this factoring, are you convinced that what is in the second parentheses is a prime polynomial? And Brian, if you want to get shots coming that way, you're welcome to come up in front. We've got a guest this morning, Brian Hill, who's our YCCD webmaster was, I'm not sure what your formal title is right now, but photographer today, and they're doing some things for the website. So any place you want to go in the room, you're welcome to. But the n squared plus n plus 16, the question here, the only factors I have would be 4, 4, 2, 8, 1, 16. But what you may have noted, perfect square first term, perfect square last term, is it the trinomial perfect square? No, because this would have to be what? I hear a 4 and an 8. Which is it? Okay, if you had n plus 4 times n plus 4, this would have to be twice 4n, double the product. So we'd be missing 8 as a factor. This is a prime polynomial. That's not an easy thing to know. All you could do now is say, look at the factors here. None of them work. You're done. Any other questions in 71 through 74?
72, we would write it as that, though. We wouldn't just...
You'd be done. You'd write the original problem and then write this, and then you're done.
Okay.
Any others? Any other questions on the homework? Okay.
Yeah.
Perry?
62.
6-2.
It might be the same issue.
Let's see. On number 62, let's see if I can get the document cam centered better. Let's try that, Debbie. Okay, I have y cubed z, and then I have a y squared z squared and a yz cubed. It looks like yz is it. Is that correct?
Right.
So I'm going to have a yz, and then when I pull that out, I'm going to end up with a negative 54 and a 3. So as I look at the numbers here, and let me just, this is 62, just the reference here is in terms of a 3 yz I'm going to have. That's going to be a positive. And then I'm going to have a negative 54, and I assume that's a z squared. And then in the front, I'm going to have a y squared. Now, I have some other garbage involved in the front. But now the question, what are the factors involved here? I have a 54. Okay, and I have to have what? A difference? The difference is going to have to be 3, and a 6, 9 has a difference of 3. So that looks to me like that trinomial is factorable. So I should be able to take that. I still have the yz in front. And then I'm going to have y, a 9z, okay, and a 6z. I didn't leave room for the z. That's making a mess that I wish wasn't there. Now the question, one of those is positive, one's negative, and now that I've committed myself to the placement of the 6 and the 9, I'm going to have to be careful to make this a positive here and a negative here. But does this now work? I have in my outer product a positive 9yz, inner product a negative 6yz, that is my positive 3yz, and so this does not turn out to be a prime polynomial. But the same analysis is going through. And I guess what I should do here, you probably aren't going to like that, because I have more room in the right, I put my YZ there where you probably put it in the other side. Agreed? Other questions? Then the usual, please. Fold those, pass them over to the side, and we will then do what is going to be called more on factoring trinomials. So let's cut to the screen for a moment. More on factoring trinomials, which means more fun, more pleasure, more excitement, and frustration. So we're going to go to a higher class of problems. These are the ones that are the expensive variety. You have to pay for these. Okay, let's just pull something out of the hat here, something that might be interesting. I'm looking at 51 on page 307. Let me try to get that a little bit clearer. There we go. So 51, let me write that down. This up here, I'll just put a reference up here. I think that was 301. And now this is going to be page 307. And the problem I'm looking at is going to be 51. And the numbers involved here. We've got a 6m to the 6th n. I have a plus 7m to the 5th. Is it n squared? Yes. And then a plus 2m to the 4th and an n cubed. Okay, as we cut to the board. Now the question. What am I looking for as a GCF? The same letter in every term. Well, first just the letters. And mn, right? So m and n are in every term. Then I'm looking for what? Lowest exponent. So what's your lowest exponent on an m? A 4. The lowest exponent on the n. Okay, we got that 1 understood right there in the first. I didn't put that 1 in, but it's a good one to include. Then I'm going to look now at the remaining parts. And by the way, the GCF of 6, 7, and 2 is just a 1. So there's nothing in common on the numerical part. So I'm going to have a 6m squared. Then a 7. I hope I have m in. Otherwise, you have to anticipate what would work here. So I have a 7m in. Then I'm going to have a 2, and I better have n squared. Do I? Okay, so at that point, we aren't done. We've got the GCF. Now I'm going to take the m to the 4th into the 1st, and now I know I want two binomials. The two binomials, when possible, take a look at any one, the first or last term, and ask, is it down to the point where you only have one choice? Only one choice for 2n squared. It has to be 2n and n. It is a plus sign, so you're talking about a sum. And since the middle term is plus, I must have a plus for each of those. I know that I have to have m and m. That's determined. Now the only question, what are the factors that I need here? So I look at the 6. 1, 6, 2, 3, and here I had a 2, 1, and a 1, 2. Now I have been reversing just one side of it. Since I've already committed to what? 2 and a 1, I'm going to take that out and reverse this side. Then I have to look at what? Pairs. Now this is the part, you see it and do it, things are great. If at this point you run into trouble here, this is crucial. Okay, so this is sort of the critical mass point for the course. If this goes well right now, the future is good. If this does not go well right now, the future is bleak. Because you're going to have to do what we're doing in this problem at this point on the fly quickly. This is an advantage to know now because Friday, you have a holiday. Monday, you have a holiday. That's 4 days to do factoring. I thought you would like that. Now that was cynicism. Okay, we want a sum of what? 7. Okay, as I look at this, what I'm seeing, what caught my eye was 2s and 3s and 2s and 1s, 4 and 3. I immediately gravitated to that. So I saw this one together. The 2's on the inside, the 3 on the outside for my 7. So I had 2 times 2 is 4, 3 times 1 is 3, add, and you get the 7. But you could just come across, and so what I'm seeing mentally is that 1, 6, 2, 1. So I'm seeing a 12 and a 1, which is 13. Then I see what? The 2, 3, 2, 1. And what I'm hoping is that you see these in your head without writing them down. Because this is a 6 and a 2, which is an 8. Then I go the 6, 1, 2, 1. And that is going to be, again, interestingly, another way of getting 8. Then I have the 3, 2 and the 2, 1 that I was seeing, and that is giving me the 7. Now notice the order already is taken here, 2, 1. I don't have to put the 1 in front of the n. But then I'm going to run what? A 3 here, a 2 here, and I'm done. Now if you see that and you see it and feel comfortable with it, from here on out it's going to be boring as sin for the next several days because it's redundancy, it's repetition. If you're struggling with this, the next several days are going to continue to be a struggle, and paying dues is what's necessary to get comfortable. And I'm thinking back of Perry's statement, practice makes permanent, and that's what I'm hoping is perfect permanence, that you get the process grooved into where you can do these in your head without actually writing down what I did here. If you're at the point you have to write all this down, you aren't there yet. You need to do a few hundred more. If you can see this up here to here, pretty much just by you wrote these down and you didn't even have to finish the list, and bingo, you're there. There's no need to carry all this out. Getting the idea? Let's do another one. So what I'm going to do, leave that one up there, and let's see if we can find something a little less intimidating for a moment. I like number 32. So number 32, we'll cut to the document cam. That's okay, I just needed to focus. 6w squared plus 19w plus 10. Now eyeball it for a moment. Now I'm going to sort of work with you on this in the sense. We see a plus 10. So what does that plus 10 tell you? A sum. The middle term tells you they both are going to be positives in the binomials. Now you see the 6 in your head, 2, 3, 6, 1. You see the 10, 2, 5, 1, 10. Now out of that mess, without writing anything down, can you do a mental combination of 2's and 3's and 2's and 5's and get out of that a 19? Or do you have to go to the 6 and 1 and 1 and 10? How many think you see in your head what it is right now? Ooh. Okay, that was unnerving. Okay, Jennifer thinks she's got it, okay? Again, let me say them. 2, 3, 2, 5. 2, 3, 2, 5. What if I said 3, 2, 2, 5? 3, 2, 2, 5. 3, 2, 2, 5. I got one more. So I'm up to 3. Anybody else think they see it? Okay, got it?
It's got to get to 19, right? That's what we're
Yep.
focusing on? I don't have it yet.
Okay, 3, 2, 2, 5. Okay, Debbie, I'm going to go to the side up here. Here's what I was seeing. Now, seeing it written that way, Are you there? Doing it mentally versus seeing that much written, because, thank you, Brian. Does that make sense? Because you're getting 4 and 15, which is 19. Okay, seeing it on paper is ahead of what? Seeing it in your head and doing it. Now, if you can see this on the board rather than paper, that's good. If you can see it in your head without having to do that, that's where I want you. Let's go back to the document, Cam, and see where this came from. We had 6w squared plus 19w, and then we had plus 10. Now, assuming you didn't see this in your head at the time, what you would do is take the 6 and 1, 2 and 3. In the 10, you take 1 and 10, 2 and 5. So you have your possible factorings by two numbers. Have I left anything out? Yes, I have, because I didn't do what? I didn't reverse one side of it. I have to reverse one group of them. So that means I get to increase my choices. But once you've done that, if you can do this, you'll eventually get there. Now, doing that without going through these pairings I'm going to do, another issue. But if you can do this much, you should be able to factor. Because what I then do is start running these as pairs like the following. 6, 1, 1, 10. Now what's necessary here? To multiply in your head and add. 60 and 1. That's 61. Is it a 19? No. So I go what? I can go 6, 1 here, or I can go 2, 3, and I don't know which way you see is going to work best for you. If I try to keep this going at the same time, I'm making this choice to cut a little bit of time for myself, but now I'm at what? 20 and 3, that's 23. Close, but not there. So I go to the next 6, 1, and 2, 5. And I think you see why I didn't go 6, 1 all the way through. I'm looking at the space constraints I have in the front board. Well, that's going to give me what? 32? The 6 times 5 is 30. The 1 times 2 is 2, hence 32. Now I get to the 2, 3, and I get to the 2, 5. And at this point, I'm going to be at 16. But it may occur to you as you see that suddenly, golly, if I just reversed that, the 2's would be next to each other, and I'd be doing 3 times 5. And that might allow you to immediately come up here and say, wow, if I did this, I'd be there and not have to do what? Grind through everything in the list. How do you know if what you are looking at is prime? You've tried everything in the list and nothing works, then you say it's prime. The only way you do that is carry through all the factorings. Now, is this seeming a little more clear where that came from? Now, what do I have to do in the next step? I have to translate this into my binomials. Now, that's the place where, historically, there have been some problems to know what order. And what I'm arguing is it tells you how you're going to do these. What you see here is going to be what? Exactly the same order I'm going to want to have happen. I want the 2's to be multiplied and the 3 and 5 to be multiplied. So I know that if I have a 3 and a 2, so what I'm going to do, not an equal sign but an arrow here, and try to crowd that in there. I'm arguing that this has to be 3w and this has to be what? The 2w. Now they both have to be plus, and now I want what? We said the 2's multiply together, and so that tells me the 2 has to go here, and the 5 has to go there. So it tells me how to arrange them. I'm done. What's the last step I want you to do? Multiply the binomials together in your head, convincing yourself that you have a right answer. Okay? So what you're going to do is look at that and say, well, I have 4W, I have 15W, that's 19W, and I'm making a rather blatant assumption here that we are aware we're going to get 6W squared if I take 2W times 3W, so I'm not really checking that. And the 10, I'm just taking for granted that that's going to work. Now, if you mess up here, and you say 3 times 5 is 10, you're toast. It's just not going to work. So there are places where it can still go to pieces on you. But this was problem number, let's come back to the book now, that was number 32. So unfortunately, I have a 3 times 2, and I have a 32, and that is not some kind of guaranteed hint. 32 will be 3 times 2. That will not in general work. Let's go back to the document cam. And so I want you to notice here, when the authors give you something rather wild, they are at least protecting you a little bit. Look at number 28. You have a 38x squared, but a 2 on the far right. So there's not much you can do with the 2, and the 38 isn't as bad as you think, because what are the only 2 products you worry about with 38? 2 and 19, 1 and 38, because 19's a prime. We need to have something maybe a little more exciting. Can we find anything more exciting? What I'm looking for, I like this, number 41. Now, when I like it, you probably cringe and say, if he likes it, it's not good. Okay, 41. I like that. 18 and 75 and a 15. Not necessarily a warm, fuzzy feeling, but it's good. Okay, Debbie, I've got to travel. Yeah, go ahead.
When you look at these problems, I mean, I'm just looking at it as a layperson. When you compartmentalize these problems, you look at the whole thing, or do you look at the...
Good question. Okay, let me try to respond to that in a moment. And the question is how I catalog this as I see them. How do I put them into some category so I know what to do to start? Okay, let me first write this one. There we go. Now, let me see if I can answer the question for you. Obviously, from what I've done, I think you've picked up I look for difference of squares and trinomial perfect squares. That's my first choice because those are patterns. I see them and I know what I'm going to go for. So in a sense, I'm always looking for special cases. And the 2 biggies, trinomial perfect square, the difference of 2 squares. We have a whole section on that coming up. But that's my first choice. If I don't do that, another first step for me is to see if there are common factors I first have to remove. So the minute I see this problem, although I was fascinated by the 18 and 75, there's a part of me that's also noticing, hey, I've got an x in every term. So I immediately, first step, can I take out a GCF? If I can, things are good. If I can't, then I'm a little bit perplexed what to do next. That's when I go to, is it a perfect square trinomial? Is it the difference of 2 squares? No, no, okay. Then my next step would be to look at the 18 and 75 and start breaking them into pairs. So that is perhaps about the 4th step in my checklist. Another thing, what I look for here is the sign in the 3rd term. Because I see that minus and that triggers what? I'm going to do a difference. If it were a plus, I'd know I'd go a plus. So that's a big issue too. So I am going through a checklist mentally, quickly. GCF, trinomial perfect square, difference of 2 squares. What's the last sign? Am I looking for a sum or a difference? Then pairs of numbers to give me, in this case, an 18 and a 75. So I look at this 18, and I'm going to break it up, but I probably, before I forget doing it, I should take out that x cubed. And when I do that, and I see I didn't do something I should have, this is not going to be as interesting as I wanted. Because the minute I started writing those numbers, I did a mental double take and thought, oh darn, this isn't going to be so fun. Because I have a 3. Not nearly as much fun. So if I take out a 3x cubed, I thought we could really get into this one. We can't. I mean, yes, it's interesting, but not nearly as interesting as 75s and 18s. Okay, so now what happens if you didn't see that 3? You could do it, but then you could end up taking a 3 out of one of your binomials, and if you didn't, would probably lose partial credit because it was not completely factored. Okay, we're ready to go with the 6 and the 25. So we have a 1, 6, a 2, 3, and a 5, 5. Now I have in the past done what? This grouping tried to reverse this, but the 5, 5 is going to be the same, so I better do what? Go back with the 6, 1 and the 3, 2. Now I want a difference. This is the hard part. Think differences rather than sums. I find from my own work that differences are a little more demanding than are the sums when I do it in my head without writing things down. They seem to press me a little bit more. So what I'm going to look at, and I'll just write these up here, trying to still make that bridge for you of can you see what you need if they're written down versus can you see this in your head without writing it down. And I haven't done any of these in my head yet. I'm still just stalling. Now as I stall and write those, and I'll just get off camera enough so you can see it, center myself in that screen, but we want a difference of what? Of 5. And as I look at the second of those 4, I see a 15 and 10 and the difference is 5. So as I look at this one right here, then the 3 and 5 is 15 when I multiply, the 2 and 5 is 10 and subtract. Would it help if I were to, for example, on paper, give myself more space? Let's slide over just a little bit in this now, Debbie, and we'll just focus here on these. Now, would it help if I did this underneath and actually write those down where you aren't carrying them in your head? That might reduce some of the stress. Because now the difference is indeed what? The 5 I needed that you can still see right here. Now, this is the critical step. If you see this, again, we're in business. And you may ask, well, wait a minute, why didn't, say, the 3, 2 work? Okay, well, if I had this one, would it work also? Well, I get a 10, I get a 15, it will also work. Why? Because I had the 5, 5 here. That happens to work both ways. But will the 6, 1 work? Well, I have 5 and 30. That's difference of 25. And up here, I still have that same difference of 30 and 5 for 25. So let's see what we're going to do with our final result here. I had 3x to the third. And I'll just rewrite this so that we can focus on the same space here. So I have 3x cubed still, and then I'm going to do what? Build the product. So I'm building a product here. Well, that sounds like an enterprise, right? We're going to build a product and sell it. I need a what? We said down here a 2x, a 3x. We said we'd have 5 and 5, so what's the only real issue? where the signs go. One has to be positive, one has to be negative. If I make this a positive here, I'd have positive 15x. I come here, and that's negative 10x, and I have my result. What happens if you instead put a minus sign here? You would find that you have a negative 5x. So if you are sitting there saying, well, I might make a mistake, I don't know which way to go, do one. If it doesn't work, go the other. It's one or the other. You're into that exclusive choice. One works or the other one works, and you're right there. Is there any discussion? Okay.
I noticed at the beginning, at negative 75, then you ended up at the end, the second part, a negative 5. Is that having a consequence?
Well, remember this 3 out here. You're sort of not focusing on that for a moment, because that 3 out there times this negative 25 is what? Negative 75. And when I take this product of these two binomials, I'll have what? A negative 25, which will get multiplied by the 3, which will give me the negative 75. But the key is you sort of throw this away in your thinking process. Well, it's not there, but it still is. So we've traded off the trinomial for the product of 3 different factors, each containing the variable. Now, again, I want to address something here. Why do we do this? Why do we factor numbers in arithmetic? There are 2 reasons for factoring numbers in arithmetic, and they are the same 2 reasons for factoring polynomials. In arithmetic, we factor numbers so we can reduce fractions. We factor numbers so we can find LCDs. That is precisely the same motivation here. We are going to reduce quotients, fractions, involving polynomials in the numerator and denominator. We're going to reduce them. And we are going to have to combine fractions containing polynomials through an LCD. This ability to factor just exactly the same issue as it was in arithmetic. Okay, so I'll leave this one up on the board, and let's take a look at another problem here and see if there's anything as a wrinkle that's going to be a little more demanding. And after the question that was raised in last night's homework, I feel an obligation to come to 67 or 68, somewhere in there. Okay, 67 looks like a nice one to go. And how am I going to... Okay, Debbie, let's come on. See if I can go up higher in the page. Yes, it seems like if I get higher in the page, I get rid of some of the glare. Let's try it. I get some spherical aberration, but you can't have everything. Okay, there's 67. I'm going to write that on the sideboard, and I hope in your head, now as you look at that, you're thinking of the question that was just asked, and that is, what's my first step? Well, certainly in what you're doing, the first step is going to be write the problem. Now, hopefully as you write the problem, it becomes very obvious to you that you are writing the same thing in each of these terms. That being the m plus 1 quantity cubed. As you write, you become aware of it. If you just eyeball it, you may not see what is alike in every term. But when you write that m plus 1 to the third each time, I hope that you see it. If you do, the next step is pretty straightforward. You're going to do what with that m plus 1 quantity to the third? You're going to take it out as a GCF. What does a GCF stand for? Greatest common factor. So I will take out here in the front, and you could technically do this at the end, but I would prefer, I think, to put it in the front. And I have a 25q squared, a minus 5q, and a minus 2. Okay, as you see, the 25 and 2, does anybody see the factoring immediately? Are we there yet for anybody? the 25 and 2. Does somebody see if this trinomial can be factored? Are you seeing it yet? 1 yes, 2 yes, 3 yes. Was the hand up, Jeff, or not? Half up. Okay, 3.5, 4.5, 5.5. Okay, if you don't see it, what are you going to do instead? What do you do next step? Write down the factors. So what are you going to write down for the 25? 5, 5, and 125, and over here 1, 2, and 2, 1. One of these has to be, one column has to be reversed. I, generally speaking, opt for what? The shorter column, unless it's what? The 5, 5 we had before, and that was all we had. Now, I think I really screwed up that last problem, and I just realized I didn't play the game fairly. I was so focused on where I wanted to go. Debbie, let's take camera 1 for just a moment and pick up the left side of this board. I've got to go back and do a public apology. Okay, so we're going to come back to that first problem with camera 1, and then I'll walk over into that. I said we had over here 5, 5. But what also could we have done? Boy, that was bad on my part. I saw the 5, 5 immediately, and I didn't consider everything, so my apologies to you. So we could have had more fun than I really did there. Okay, I'll go back to where I was. Now, what are we going to do? Well, probably the best thing is to just give yourself some space and maybe make these loops big. What didn't I do that I perhaps should again focus on? The minus sign in the third term tells me a difference. That's what it keys it. So I'm looking at a 5 and a 10 when I do that first one. And what does that give me when I do a difference? 5. I don't have to go any further. If you're lucky, you get it quickly. If you're not, you may have to go through all of them. You have 2 here, that's a total of 4 that you're going to have to consider. We got it in our first shot. So after a while, you're going to develop a kind of sixth sense of going for it rather quickly. For example, if I know I have to have a small difference here, I'm pretty inclined that it's not going to involve a 1 and a 25. If the number in the middle is small, then I'm going to go for the smaller factorings of 5, 5, and 2, 1. That was what was motivating my choice earlier when I just wrote down a 5, 5 and said that's all I've got to do. So what's going to happen in this result? Well, I'm going to write m plus 1, and I think I'm going to write it above now, so I still have some room. I'm starting to cut myself a bit short in room here on the boards, so I have to write some binomial parentheses here. Those parentheses are very critical. And we said it's going to be what? 5 times 5. So I know I'm going to have 5q and 5q. Now, I said I have to have a 1 and a 2 in the second. Well, if I haven't thrown signs in here, it's pretty arbitrary because I have a 5 in each. So that's going to work either way I go. But now, where do I want my signs? Okay, the negative with the 2? Is that making sense to you? Because if I make that a negative, then I will have a negative 10q, then the positive 5q, and that gives me negative 5q, and I've got it. Now again, if you're getting it, it starts getting a little bit boring and routine. If you haven't yet managed to get it, then you just need to do more and more and more until you say, ah, I've got it. Okay? Any question on this one before we try to look for another one? Well, let's go back to the document, Cam, Debbie, because I think all of those from 67 to 70 are done the same way, aren't they? So that's a fairly standard procedure there. Which one now? Okay, let's come off there for a moment. 59 is something of interest. Oh, I know why you chose this one. Okay, 59, what is being done here is noticing, and it's similar to the question we had yesterday about the 1 minus A, 1 minus B, as compared to A minus 1 and B minus 1. Negative first terms are not good. Okay, I'll just put that as a generic statement. A negative first term in a trinomial is not good. So I'm going to, with some space, I just can't let this space disappear. So I'm going to write negative x squared minus 4x plus 21. And thank you for picking up on this one. As I look at this, I don't want a negative x squared. I want an x squared. I want life to be good. So I'll factor out minus 1. X squared plus 4x minus 21. Okay? Doesn't that allow me now to play the game the way we've been playing? Now I'm looking at a difference because of that third term. Who sees it? 2, 3, 4, 5, 6, 7, 8. Okay, anybody else? Keep looking. 21, think of the factors and think differences. What can you multiply together to get 21? And you want the difference of those two numbers to be 4. I hope a 3, 7 is in your head. The 3, 7 is all you need. The thing that makes that work is this is what here? A 1 in front of the x squared. As long as you have that, then just the factors here become your focus. So that's going to be a negative 1 now, and then you have the parentheses, and there's a certain part of this that you can do no matter if you see it or not. You know this has to be an x, and the second parentheses has to start with an x. No question. Now your choices for 21 were what? 1 and 21, 3 and 7. 1 and 21 have a difference of 20. The 3 and 7 does have the difference of 4. So I could put a 3 and 7 in this way, or I can reverse them. But if I do it in this way, I must put my plus 7 with my minus 3, and does it work? We've got it? Any questions here? Okay, I'll leave that one there. Let's go back to the document cam and see if there's... Do you see in 61 you're going to do the same game? You're going to do the same game in 63. It's just the nice first step so that you can keep asking the same questions, because I'm backing myself to the question that Coda asked, and that was, what do I do first? And the first thing, get it in a form that's constant, consistent, so you can always ask the same questions. Going down into 71 through 74. Let's look at 73 just as an example. We have 2m squared plus km plus 5. This is working backwards. This is sort of neat. I've asked you this same kind of question before, but let me write the problem first. This is number 73. And in 73, I have 2m squared, and I have a plus km and a plus 5. Now the question, if you were making the choice for k, so this could be factored, what would be the choices you could use for k? And it would work. K could be what? And be able to factor it into a product of binomials.
11.
Okay, 11's a good number. Any others?
7.
7, 11. You have any, as you look at it, now that you've heard the numbers, do you have any way of seeing that?
4 times 2 is 10.
Okay, I'm seeing several heads nod, looking for not the glass look in the eye as you are rolling it back in your head, but that moment of, yes, I've got it. Okay, 2 can be 1, 2, 2, 1, correct? And the 5 can only be done as 1, 5. I only reverse one of them. Because they were prime numbers, I didn't have a lot to consider. So if I were taking these, and I had a 1, 2, and a 1, 5, I would have to have that as my inners and outers, which would give me 7. If I had the 2, 1 and the 1, 5, I would have 11. So what are the only 2 possible values for k that I could use so that I could write it as a product of binomials? The answer is 7 or 11. One or the other. We'll do it. We had done that yesterday and the day before a little bit in the same way. Now I'm going to key on a comment again, coming back to that question that was asked. What kinds of things do I look for? So we're going to come back to that infamous 80. Okay, so I'm going to leave this on the board. Now I'm going to go back to the page where we had 80 problems. We're getting closer to that every day. And one of the things you may want to do during the 4 days that we have coming is sort of mix and match, if you will. Let's see if I can get this to where it looks good. Let's see, I'm going to get all the way up to this list. I'm on page 317, folks. Now my hope is you look at 1 and you go, all right, I'm there. I want you to stare at number 1 for a moment. You have a squared minus 4a minus 12. So my question as you look at that, what is it you take as a first step? Well, do you see anything other than a 1 that's common to all the terms? The answer is no. The GCF is 1. Then you note the last term is negative, so you want differences. Then immediately you see the 12 and you ask, what can I multiply together to get 12? Your choices: 1, 12, 2, 6, 3, 4. Do any of those pairs have a difference of 4? That's the question. The 6, 2 did. And from then, the good times roll. So, let's go back to Coda's question. I see a bunch of problems, 80 of them. What might I do in scanning through those, hunting for the, what we might call the freebies right now? The ones that you got without any real problem. Well, number 1 was like that. Now, I want you to scan for me. Going down that first column, do you see another one as quickly that catches your eye? So let's go back to the camera for a moment. You're looking at that first column. Is there another one that catches your eye in the same genre? Number 1 and just what we're looking at on the screen now. Look at the screen. 1 and 3's harder. Not the same difficulty level as 1. I want 1 in the same difficulty level as 1. 7. You betcha. 7, same difficulty level. Come off there for a moment. I'm going to just skip to the next column. And again, I'm hunting for something like what we saw in the first problem. Do you see anything there? Does 2 just hit you? I mean, like, give me a lot of those. I want 100 of them, and I'll get this course aced. What do you see on 72 that catches your eye? What does the 72 look so good? Anybody? Tell me.
8 and 9.
8, 9. 8 times 9 is 72, and 8 and 9 is 17. And again, the good times roll. Okay, let's come off there for a moment. And let's see if I can find one for you. 49. Does 49 look good? Okay. I hope you see 49 and say, oh yeah. So what could you do right now. You could start going through and hunting for what? The nice ones. That's a pattern. The nice ones, the ones that you don't have to struggle doing. Compare that to, now I do this with some concern. I just lost the problem. I saw it and then I couldn't see where I was going with it. 42. Okay. 42. Okay, I heard a and an ick and an oh gosh, oh darn, don't want to do it. But do you see the common factor, the p to the 8th that can come out? And then do you see that a 3 will go into everything minimally and maybe even a what? A 9 if things are good. Now the point there in 42, it looks bad, but when you take out the GCF, life gets good. So what else could you do in this entire list? Go through and hunt for everything that has a GCF you can pull out. And maybe you'll be lucky in what? What's left is one of the good guys. I'm encouraging you to start looking at this list with the idea hunting for the easy ones.
Would you consider number 48 an easy one?
48. Okay. 48, the answer, would I consider that a nice one? And the answer is only after the GCF comes out. The 5Z. When it, is that Z?
Yeah.
Yeah, the 5Z, it comes out, yes, life gets good. Now, I need to come to something that is maybe in your mind not so good, but in essence is good. I want you to look at 24. That's the one I'm going to close on, 24. Does it look good? What I'm hoping you see is a difference of squares. M squared minus 9 squared, so you have m minus 9, m plus 9. That's another group I look for. Okay. We aren't going to do those technically yet, but you may want to start working in those. So I understood from what Lorna said that she wanted an assignment more like last night with a lot of problems. So I'm looking starting on page 306 with number 17. That looks good and goes all the way down to 74, but that would be 60 problems, and that's probably too much, even though Lorna said she wanted all of them. 17 through 74 odds. And Lorna can do them all. 17 through 74 odds on this one. But take a look at that list of 80. I'm down to a minute and less. Debbie, we started with Fleetwood Mac. What's your choice as we close?
Never going back again.
Oh, never going back again. All right. Have a great morning.